Okay, this lesson is on interior and exterior angles. We're going to start by working out the sum of interior angles on a polygon. Then we're going to move on to finding the size of one interior or exterior angle on a regular polygon. Then we're going to look at finding the number of sides a shape has if we know one interior or exterior angle, and then we'll move on to our problem solving questions. Remember to make notes as you go again. Rewind and listen again if you need to. There will be a chance to pause and complete an activity and avoid distractions. Okay, we're going to start with some key terms. So a polygon is a 2D shape with straight edges, and a regular polygon is a 2D shape with straight edges where the lengths are equal and the angles inside are equal. So interior angles, they do what they say on the tin. They are the angles inside of your polygon. We can use some basic facts that we know a triangle has a sum of interior angles of 180 degrees. And then our other polygons can be split into a number of triangles. So this square can be split into two triangles. Each triangle has a total of 180 degrees in. So that's two lots of 180 degrees. Gives us 360 degrees for a square. Likewise, we've got Pentagon. Can split this into three triangles, that's three lots of 180 degrees, gives us 540. By now, a key formula should have popped back into your head. We've got a hexagon, last example, four triangles, each one has 180 degrees, that's four lots of 180 degrees, means the total sum of interior angles is 720 degrees. You should also be able to spot a link between the number of triangles that you can make inside of a polygon compared to the number of edges each one has. If we know the sum of interior angles, we can then find out the size of each angle if it's a regular shape. So equilateral triangle, which means all three angles are the same, we can just divide by the number of angles. A square, by definition, is only a square if all of those edges are the same. Each one is 90 degrees. Pentagon, we've got 5 angles, so we divide by 5. And a hexagon, we've got 6 angles, so we can divide by 6. Exterior angles then. They are, again, do what they say on the tin. They're angles outside of your shape. If you was to extend all of your interior angles, they end up on a straight line. And if you was to walk all the way around your regular polygon, then you would have always completed 360 degrees. So key point there, that exterior angles always total up to 360 degrees. So one way of finding out the size of an exterior angle would be to divide 360 by the number of angles. So in this case, 360 divided by 5, which means an exterior angle would be 72 degrees. The other way we could do it is that if we could use the fact that interior angles and exterior angles are on a straight line, and we know angles on a straight line add up to 180, so taking from the slide before that an interior angle on a pentagon is 108 degrees, if we take that away from 180, again, it gives us 72 for our exterior angle. So two ways of working it out. It's nice to be able to work interchangeably between interior and exterior angles. So if you have one, you can calculate the other. Right, this is the key formula I was referring to earlier, and you should have spotted the pattern that to get those number of triangles, each time we took 2 from the number of sides and then multiplied by 180. So this was our number of triangles, and each triangle has 180 degrees, so we can multiply. So to work out the sum of interior angles of any polygon, you can do the number of sides, subtract 2 times 180. To work out the size of each interior angle, it only works for a regular polygon, then you can divide the sum of interior angles by its number of sides. Exterior angles, they all total 360, so for a regular polygon, to find out the size of each one, you can divide by 360 or subtract the interior angle from 180. They're your key points. So let's have a go at some example questions. How can we use this together? So first of all, key information in the question is that we've got a regular hexagon, and BE is a line of symmetry. So B to E is a line straight through the middle of our shape, and this side will be equal therefore to this side because it's a line of symmetry. So first of all, we're asked to calculate the size of angle ABE. So remember, that's joining up A to B to E. So the angle is here, that angle here. So first of all, let's use the key point about the exterior angles in a hexagon. We know our exterior angles total 360. So divided by 6 means the exterior angle is 60 degrees. Therefore, the interior angle on a hexagon must be 120, and ABE is therefore 60 as it's split in half. So we've worked out the exterior angle. So if we extended this line here, we've worked out the exterior. We've taken away from 180 to work out the whole of this angle. So to work out ABC, the whole one would be 120, and then we've had to half it because we've used the line of symmetry. Next question, we're going to work out the size of angle DCE. So D to C to E. They've used the line that goes straight through E to C, and we already know that EDC, so this one here inside, would be 120 because we've worked that out already, that the interior angle of a hexagon would be 120 degrees if it was regular. And we also know that because it's regular, ED will equal DC, therefore we've got an isosceles triangle. So the two that are left will have to be equal. Triangles add up to 180 degrees, so if we subtract our 120 between this one and this one, we've got 60 degrees to share, so each one must be 30 degrees. Okay, last question. We've got to calculate the size of angle BEC. So from B to E to C. This one here. BEF must be 60. So if this one here is 60 and this one here is 60, for the same reason as question A, that the whole thing's 120, and we've got a line of symmetry. And we know CED is 30 from the previous question, and we know that the whole thing has to total 120 because we've already worked out that. So by subtracting our 90 degrees, we're left with our angle here of 30 degrees. Okay, moving on to a new question then. So a regular polygon has an exterior angle of 18 degrees. How many sides does it have? We've already said earlier that we can work out an exterior angle by doing 360 divided by the number of sides. So we've just got to swap that around a little bit. We want to work out the number of sides. So we've got the answer, but we haven't got the number of sides. So a bit of a rearranging on here means the number of sides is actually 360 divided by 18, and the shape would have had 20 sides. They very often will give you part of a shape in an exam. So same sort of thing. We now know the interior angle. So there's one extra step, because if we know an interior angle, we can work out the exterior angle by doing 180, subtract that. And then same as before, if we do 360 divided by the number of sides, we would have got the answer 24. Rearrange that. We want the number of sides, so we've got to do 360 divided by 24, and the number of sides would be 15. Right, this is your turn, please. I'd like you to take the opportunity to pause the video, work out the sum of the interior angles for the polygon with this amount of sides. As an extension, you could work out the sum of one interior angle if it was a regular polygon. If you could pause it now, please. Okay, here are your answers on that. So before we move on, let's just check you got this one right, for example. So it's always the number of sides, subtract 2, and then times 180. So you should have done 48 times 180 to get this one, and if you moved on to the extension, you should have then divided that by 50. Right, step harder. We've got to work out the value of x in each case. If you could pause this now and have a go of that, and then we'll go through the answers. Okay, so here are the answers. To work these out, we've got 2 pentagons, so we have to work out the interior angle of a regular pentagon by doing n minus 2 times 180 and then divide by 5, so we get that each interior angle is 108. All of these angles here must add up to 360, it's a full turn, so 360 subtract 108, subtract another 108 will give us 144. Last shape for you to have a go at. So shown is a regular pentagon, you need to work out the size of angle y. If you could pause it now and have a go, please. Okay, let's have a look at this answer. So same as before, we've got a pentagon, so the regular pentagon has one interior angle of 108 degrees. Then we're given an isosceles triangle because it's a regular pentagon, so 180, take away 108, then divided by 2, which means y would be 36 degrees. Okay, so we've looked at interior and exterior angles. We've looked at calculating the values of interior angles in a polygon. We've also looked at how to work out exterior angles. And I'd like you to head over to Teams and complete the corresponding activity. Thank you very much.